Good afternoon, participants. As you are aware, today's webinar is on the smart indoor air quality monitoring. And we are also aware that current environmental condition is very alarming, particularly related to the air quality condition. So today, Mr. Vikas Saxena is having almost 27-year work experience in this particular IoT and smart devices. And he is also the CEO of the Caleedo company. He will share his insights and experience how to use and explore these devices in our workplaces. So now, over to you, Mr. Vikas.
Yeah, hi. Thank you, Vaibhav, and a very warm welcome to everyone. And thank you for also sparing out some time for the session. So I will just put on my screen and do let me know if you find any difficulty in getting to see this. Is this visible now to everyone?
Yes, sir.
Just a reason. Brilliant. So I believe the subject both ways very relevant. Of course, from the point of timing, I think all of us today are reading it as one of the top headlines in the newspapers. We have had our own personal struggles in the daily life in terms of commuting. A lot of vehicular traffic has been stopped. A lot of construction has come to a halt, and we know that the air quality outside, and of course there is an impact on the indoor air quality. How that continues to impact the health of the individuals at workplaces. What we're going to discuss today, of course, is what is this indoor air quality that we're talking. I'm hoping that most of you know about it, but I will just kind of recap what it is, what are the major constituents around it. Um, Sorry, what are the major constituents around it? What are the health impacts of these constituents on the human health? Um, of course, then we will talk about how today, with the advancement in the technology, we can monitor these various constants of the indoor air quality. Uh, what kind of information is available, and how we can circumvent and prevent a lot of the adversity that this indoor air quality continues to, kind of impact us adversely. Then we look at benefits and ROI, both in terms of tangible and intangible. How these implementation strategies do help us. Uh, we surely, while we do this implementation, now you need to appreciate that there are both kind of facilities that are currently available in India as a workplace. One, which are being built new, and knowing that indoor air quality has become a larger threat than what we used to, kind of consider, let's say about 6, 7, 8 years back. These Most of these green belts today are being complemented with the indoor air quality monitoring and remediation strategies right during the design and ideation stage. But then, of course, there are lots and lots of brownfield properties in this country where this implementation needs to take place. These are buildings which were, let's say, built about uh, 20, 30, 10 years back. And we know that these are again today house a lot of occupants who also need us exactly similar kind of monitoring and remediation. And knowing that these implementation strategies, when they are put to execution on site, there are certain best practices that we should consider while we're doing this. So we'll talk about all this, and I also would encourage, in case you have any query question, you are free to ask me for any clarification. B, in case you want to note it down and ask me as at the end of the session, I'm more than happy to answer it. So indoor air quality, as I stated, is basically the air quality within the buildings and structure, and what is the impact that it has on the health and comfort of people who occupy them. Now, typically in today's parlance, we call these kind of structures and buildings, when we were to exclude residentials, we call them a workplaces. Now, there are certain key parameters which are constituents of this indoor air quality when we look at it. The first one, I think all of us have been hearing about this nowadays a lot, and there are a lot of public displays across the city which continue to relay this, is the particulate matter, or it's called PM. And these are classified as PM 2.5 and PM 10. There is, in fact, PM 1 as well. I'm not touching upon that today. See, reason being that PM1 is just an evolving criteria. It is a much smaller particle even than PM 2.5. And the current standards fundamentally are around 2.5 and 10. PM1 follows the same standard as PM1, PM 2.5. The second most critical element that impacts the indoor air quality is carbon dioxide, CO2. I think we've read it right from our childhood that what we inhale is oxygen, what we exhale is CO2. So it's a very commonsensical understanding that if you had a space which was too crowded, too densely crowded, then of course the CO2 levels in that space will go up. And I think we have all experienced it in our own personal experiences that if we move into a very crowded space which is enclosed, we start feeling suffocated. And that suffocation fundamentally is happening because there is a lot of CO2 which is being exhaled. But we'll still touch upon it again in slightly detail in the later slide. Third, we talk about volatile organic compounds. Now, as the name suggests, these are compounds like formaldehydes and toluene, others, which are produced by products like paints and adhesives and a lot of other resources which are available. So again, if you relate to your own experience, you will realize that at times when you walk into a freshly painted office, you get to smell something which is very peculiar, and at times it starts creating a lot of nauseatic feeling or headache. And that smell basically is coming out of that paint which is emanating VOCs. Temperature, humidity, I think we understand again very well. Temperature is and humidity are basic elements that define the comfort in our workspace. Again, anything which is below a defined temperature as or above comfort level of temperature or humidity starts causing us irritations or itchiness and discomfort. Carbon monoxide, nitrogen dioxide. So I'll just talk about all these in slight detail. So when I talk about particulate matter, just from a point of definition, what it is, it's basically a microscopic solid or a liquid droplet in the air. I think all of us who've been driving, especially in the NCR region, participants who are part of NCR region, I think we faced it over the last 2 weeks very extensively, where we've seen something which looks very similar to a fog, but we all know that's a smog, and that fundamentally has these droplets in the air which kind of condense to give us an impression. And we also know that the government has gone ahead and taken a lot of remediation steps, including implementation of GRAP 4, to ensure that they're able to bring it down. This, of course, includes various kind of particles which emanate out of chemical, metal, soil. But I think the major constituent still remain the soil and dust particles. One of the other constituents that we know in North is basically the stubble burning, which happens out of the crops, which are burnt in primarily in the states of Punjab and Haryana. And God forbid if the wind direction is towards NCR, then a lot of that continues to come to our cities and create us a problem. Um, so these are categorized majorly as PM 2.5 and PM 10. Now 2.5, as the name suggests, is fundamentally because the particle size is smaller than 2.5 micrometers that we're talking here. Now, in terms of a layman's understanding, this particle is about 1 by 30th of the width of the human hair, and it can stay airborne since it's a very small, lighter particle, stay airborne for days and weeks. And the reason why you find it becoming more prominent during the winter seasons is because the temperatures are low. In the summer, these particles tend to dry up, and then, of course, you've seen today the strategies to basically make them wet with the water dispersion that is done through the trucks, and ensure that these fall down and are on the ground. Um, Health impacts, these particles being smaller, and since these are part of the air quality which are available outside, and in case they're inside as well, then these tend to penetrate your lung tissues when you inhale this as part of the as part of the air that you're breathing in. Once it penetrates tissues, it can also enter your bloodstream. Over a long-term exposure, it can cause respiratory and cardiovascular issues. Now, these are an overexposure of this, of course, is very, very lethal. There are cases that have been related to the deaths that have been caused because of the PM 2.5 and 10 and indoor air quality inside the human beings. Common sources, of course, smoke from cooking, vehicle exhaust definitely is one of the large contributor to it. There is some amount of emission that also happens out of printer emissions. Stubble, as I said, is a very geographical specific observation that we've seen in the north, which contributes a lot. PM10, on the contrary, is a particulate matter again, where the size is smaller than 10 micrometers, but larger than 2.5. But still, it is inhalable along with the air that we do inhale. Since it is slightly larger and heavier than PM 2.5, it settles much faster. Again, it can enter nose and throat, can trigger asthma and allergies. All of us today experience a lot of cough that we believe is because of cold, but the major contributor again towards that is the PM10 that we are inhaling. And at times we've also felt the eye irritations. Now, these, of course, come out of dust from construction sites. So, I think the first thing that happens when Grab 3, Grab 4 comes in, the Supreme Court ensures and the government ensures that the constructions are put to halt. Um, there are industrial processes where the burning happens, where chimneys do emanate. There it can. Pollens again is a seasonal phenomena when during especially during the autumn season it happens. And mold spores. Mold spores are basically again if there is a mold which happens in the duct which is feeding to your air conditioning. The second critical parameter is carbon dioxide. Uh, it's a natural component of air. We do exhale CO2. We intake oxygen. But the impact of this excess of CO2 is fairly lethal. Anything between 400 to 1000 ppm is considered normal, which is safe limits. You do not get impacted. But the moment it starts exceeding from 1000 and till the level of 2000 ppm, ppm is parts per million. There are, again, basis an individual's own health conditions. Uh, there, there are complaints that may arise of drowsiness. 2000 to 5000 ppm, of course, you start getting headaches. Your concentration starts dropping. You can have sleepiness. And of course, 5000 ppm and above, I think the oxygen displacement concerns start, which means that, this is one level where you may start feeling you could actually faint as well. Sources, as I said, uh, fundamental sources, human breathing itself. You put a lot of people into a space, into an enclosed space, and you defy all the occupancy logics. Typically, let's say when you go into an exhibition hall, which is overcrowded, I think we all experience this suddenly the discomfort in terms of our breathing, in terms of our restlessness goes up. That's basically where the CO2 is being added with a lot of people within a confined space. So that's one. Combustion does produce CO2 as a essential element. So we all understand the constituents of fire very well. So one of the addition is that. Um, when I said large gathering and confined spaces do add to this. Uh, Third is volatile organic compounds or VOCs as they are called. Uh, uh, it could be the gases which could be emitted from the solids or liquids. I gave an example of the fluids. Uh, these could come out of different chemicals. So to classify it as one single is very difficult. So it's a huge range. But then some of the more VOCs, which are more prominent, includes formaldehyde, benzene, xylene, toluene, ethylene glycol. Now, these come out of now if you experience within your offices, at times when the cleaning happens in your own offices at your workstations, and if the agents being used for cleaning are not organic agents or not water based and they're chemical based, I think a lot of people have experienced some kind of itchiness at that point of time. Uh, 1 second, please. Uh, Second is, of course, when you do carpet cleaning or you bring in new furniture, you do painting, you do varnishing, uh, even the air fresheners that are used inside the washrooms, which have alcohol as an agent for dispersion, also do carry VOCs. And then, of course, printer copiers. Now, what's the impact? Initial basic short-term impact is eye throat irritation, headaches. Headaches can happen. Long-term exposure of VOCs could cause liver and kidney damage. It could also these are also going to be uh, carcinogenic, so they also have cancer risk and they can trigger asthma as well. Um, Fourth element that we would look at is temperature humidity. So the optimal temperature range, which is defined as 20 to 26 degrees centigrade. Anything below this or beyond the 26 is something which causes discomfort to human beings. It does affect our productivity or the occupants' productivity to quite an extent. It does surely impact the HVAC efficiency as well. For all of you who understand mechanical as a subject, you will know that most of our control strategies for the air handling units today are based on temperature and humidity. So, of course, there is an efficiency impact directly the moment you have temperature ranges which are running beyond this. There are a lot of considerations that we need to do when we do the design of a building with regards to HVAC. As I said, they fundamentally work on temperature target. I believe there are very few specific applications that also take pressure, but most of the office spaces only work on temperature and humidity. Considerations including seasonal variations. We know, especially across India, most of the regions go through a seasonal variation, and that means that there has to be a shift in your HVAC strategy by the season. You also need to look at consideration from a point of occupancy patterns, in terms of how the building gets used across the day and what are the occupancy patterns. And then, of course, look at the building zones to ensure that you're operating within the optimal range. For humidity, it is defined as 30 to 60%. If there is humidity which is lesser than 30%, again, that does cause dryness, which again is not the best thing to have if you're having dry skin and dry eyes. That also does lead to a lot of irritation, and it can also cause respiratory irritation, which means the dryness can go to the extent where your respiratory system also gets impacted. If the humidity is high, it does act as a catalyst for the mold growth in the ducts. It may cause even the dust mite proliferation. Bacterial growth starts, supporting that, and then of course leads to a lot of material degradation. Any material, including even wood, if it is prone to exposure and is not waterproof, then that may also get impacted. Um, the fifth element is carbon monoxide. I think one of the most lethal. We've all heard about silent deaths. It's a colorless, odorless, toxic gas. It's lighter than air, results from incomplete combustion. So typically, in the old homes, wherever the angitis were used, and if you did not have ventilation, so angitis typically tend to produce incomplete combustion, and that does generate carbon monoxide. So any faulty heating system will produce incomplete combustion, and that will carry carbon monoxide. Vehicle exhaust has some level of carbon monoxide, gas sometimes, and fireplaces. As I said, MGT is Indian version of a fireplace. Uh, Different ppm levels, but anything which goes beyond 400 ppm becomes life-threatening. I think again there have been many cases, especially in the rural areas, where people have died silent deaths, where the MVTs were kept on, even in the newish towns as well, where heaters do get used and there people sleep in confined spaces. There have been cases. So, uh, carbon is another element that needs to be really monitored very closely for any adverse impact that it may create. Uh, the last element that we will look at here is nitrogen dioxide. It's a reddish brown gas. It has a slightly a biting odor. It's a strong oxidant. Again, comes out from space heaters, gas stoves, vehicle exhaust, industrial process. Impacts respiratory irritation, increase asthma symptoms, reduce lung function, and enhance sensitivity to allergens. Now, what are the various health impacts that could happen? Um, as I said, coughing and wheezing is one of the most visible and experienced impact. I think it's a short-term impact. It if exposed for a long time, any of these elements, it can cause shortness of breath, throat irritation, nasal congestion, and increased mucus production. I think mucus production is being experienced by most of us today because of the way the air quality is in the NCR. Uh, Asthma is, of course, caused majorly by particulate matter. VOCs at times, if there is an overexposure, can cause acute attacks of asthma. Temperature, humidity may not be the direct reasons for that, but they surely do affect the symptoms of it. Um, Bronchitis, which is of course again uh, a graded version of the infection, happens from NO2 exposures or chemical sensitivity from VOCs or inflammation of PM. Um, High risk groups include children, elderly, asthmatics, people with COPD, and immunocompromised individuals, people whose immunity is low. They are at high risk, but that does not mean that the people who have not been covered do not get impacted. Uh, High risk, when we say, these are people who have a higher risk in terms of the health impact that these overexposures of these elements may cause, but that does not take away the risk that the other groups, which means the youth and the other people, do carry. Their impact could be a short-term health impact, but again, overexposure would adversely impact them as well. Second, what it does is it also impacts your cognitive performance. Now, cognitive means that um, uh, your ability, uh, the brain's ability to coordinate with your five senses. Um, so it does impact your cognitive performance. Short-term effects could be that your attention span would decrease. Of course, CO2 is a major culprit in that. Your decision making could go down if there is an overexposure. Um, I believe again, when we are into a place where CO2 presence is high and we start feeling drowsy, I think that's what this refers to. That at that point of time, you yourself experience that your decision making capabilities start going down, or you are slightly slow in responding to a situation. Information processing, which means that your brain is not able to process and send out the signals to your various senses to respond, react. Um, it does also cause workplace impact. Now, any workplace which has a issue with the indoor air quality and where there are issues related to the cognitive performance, there is surely going to be a productivity loss. When you have people who are operating out of a badly ventilated space or a highly crowded space or a space which does not have the right IAQ, their ability to perform tasks does start deteriorating. Maybe not for all the people, but few of them. and that accumulated does lead to a productivity loss. There are studies which have been carried out globally, which indicate that there could be a 6 to 9% decrease in productivity. The error rates could increase in terms of being right the first time may not stand true. That people who get impacted may, commit errors. Um, since the productivity goes down, you tend to take longer time to complete the task. Um, People tend to fall sick much frequently, which means that there is a decreased attendance or absenteeism goes up. Uh, Effectiveness does go down because there is reduced participation. You know, there is poor concentration, and then there is less uh, creativity around problem solving. So all these are the direct impacts that do happen. I think we have remained ignorant to these, presuming that these are individual health conditions of a person. But the reality is that bad IAQ has been the major contributor for a lot of these such cases which has happened in workplaces. Long-term health effects do include cardiovascular, systems getting impacted. As I said, if they do penetrate your bloodstream, then there is a higher risk of heart disease. Blood pressures can go up. Um, Heart rhythm can become irregular. Blood vessels can get damaged. Respiratory systems can get damaged in terms of a permanent lung damage happening. Chronic inflammation can happen. Um, VOCs being carcinogenic can cause cancer. Uh, there could be neurological impacts as well in terms of memory problems, concentration difficulties, mood changes, behavioral problems. So there are a lot of global data studies which are available, and there is still a lot of research being done to really get to that crux of what's the exact impact. But definitely, a lot of studies are already available which do clearly indicate that offices or workspaces that are not properly ventilated or overcrowded or have bad air quality do have these kind of problems with the occupants who work there. You will also be surprised. There is a study which also indicates that um, an office with a bad indoor air quality has a higher attrition rate, which means that the employees tend to leave that organization much faster. Now, anytime, I'm sure all of you again would agree that anytime you have a loss of an employee or a loss of a team member, apart from the direct impact that it causes, there is a lot of opportunity cost also which gets lost because you need time to backfill that position. B, anybody who exits from your organization for such kind of issues does carry a bad brand value of your organization, and that also is the indirect impact that it has had. There is something called sick building syndrome. I'm not sure how many of you heard about it. It's not a new phenomenon, it's an older phenomenon. But that again is something that where the buildings do not have the proper indoor air quality. The people do experience acute health effects. Um, so people, while they come in, so they come in from outside, they are much better. When they enter the building, they start feeling slightly sick, drowsy, nauseatic, and again when they exit in these things, they start feeling better. So which means that the building is the reason why they start feeling not so healthy. Um, as I said, the some of the common criteria do include this. Again, the impact could be that their productivity does go down, their concentration does fall, they start feeling irritated, they may start feeling irritated, and they could be depressed as well. IAQ has impact other than the health impact, it has an economic impact as well. As I said, lost productivity would mean that you perform lesser tasks uh, uh, in a day, which means that the return per dollar being spent on people is lesser. There would surely, if your organization does cover the employees' healthcare costs, then of course, in such organizations, people will tend to fall sick much faster or more frequently, and that would mean that the organization would have to bear a higher healthcare cost. Absenteeism does increase in such organizations, and every absent day means that there is a direct dollar impact on the overall organization's productivity output. And such buildings also do face frequent maintenance requirements, which again is a direct cost impact. From a social impact perspective, the worker satisfaction does go down, which means that the occupants do not feel very comfortable working in such organizations. In case it's a school, the performance of the student slash worker may go down. There is a healthcare burden that they carry from a point of view, and their quality of life does get impacted badly. It does lead to, for sure, a bad brand for the organization. It does lead to a higher attrition for that organization. Environmental impacts are higher energy consumptions. Resource utilization again is not the most optimal. Um, Sustainability agenda goes for a toss in such cases, and of course, when you consume more energy, you, instead of reducing the carbon footprint, you start actually adding to the carbon footprint across the environment. So there are very, very serious impacts of this IAQ. Now, when it comes to IAQ monitoring, there are various kinds of sensors which are used in the field. Let me first go to the next slide. So, if you were to look at an IAQ sensor, as I said, there are various constituents of the IAQ. And of course, these constituents would not appear as separated out constituents. So, usually they will exist as part of the air that you're breathing in, which means that they get mixed in various compositions depending on the various sources in that workplaces. So most of the times, what you find available in the market are combined IAQs. Now there could be various IAQ combinations. What I've depicted here is the most prevalent one, an IAQ which can monitor 11 parameters at a go. We've spoken about particulate matter. So this IQ is basically an IoT device, which means that device has various kind of sensors built inside it. These sensors do capture various components or various constants of the IQ like PM, carbon dioxide, carbon monoxide. We're talking of NO2 here. Ozone is another one which I've not touched upon, formaldehydes, TVOCs, and temperature humidity. Now, these sensors uh, uh, would capture individual constituents, aggregate the information basis the uh, values that they're recording, and then would communicate this. Since these are IoT devices, these will communicate the various information to an application layer, uh, either directly over a wireless, over a Wi-Fi or a GSM network, or through a middleware, which could be a gateway controller to that through that, which we I'll just talk in the architecture. These are available as both. So the preferred ones are the fixed type IAQ monitoring stations or sensors. As you see in this diagram, there is a white unit which is shown. Those are the preferred ones because there is a defined frequency at which you should monitor these constituents, which means that basis what constituent you're monitoring, typically it will range between 1 minute to 5 minutes that it should be monitored in terms of a polling. But there is there are a lot of spaces inside an office. Let's say you have a meeting room or you have an individual cabin where only one person sits in. Now, there your occupancy patterns may not vary a lot. There your usage patterns may not vary a lot. In such cases, you could also, instead of putting a continuous monitoring system, because let's also be honest that every time you invest in a sensor, there is also a cost uh, 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 fundamental that you need to evaluate. Cost optimization also should be thought through while you are proposing a technology. Now, in open workspaces, where a lot of people come in, where a lot of occupancy pattern changes happen, where the usage is impacted by the opening and closing of doors. There, we should typically take continuous monitoring stations. Let's say we are talking of large atrium areas, large workplace areas where people work, or receptions, or conference, large auditoriums. There, of course, fixed sensors type should be used. But for individual cabins, for smaller meeting rooms, we should typically, we can, I'm not saying we should, but we can again do a similar kind of a IAQ check or IAQ monitoring through a handheld device, where which you see here again as something which is shown in a gray sensor. It's a handheld sensor which can be carried to the area that you want to monitor, and it can record the value in that area and send that value again over a GSM to the application software. So that is how we should use our own judgment to decide what kind of sensor. But these are commonly available sensor. Again, as I said, these are IoT devices. Fundamentally, have various kind of sensors on the board. They have a power source which is built in to power these sensors. They also have a communication board to ensure that they are able to communicate. So those are the major constraints of these sensors. I'll just go back to the architecture from a point of how this works. Uh, so, what goes in the field, as I was defining in my previous slide, is called the sensing layer, which means these are the sensors, and in case you are also doing some kind of an actuation. So at times we also use indoor air quality to turn on and off the fresh air dampers, or to add fresh air inside a space. Now, if I'm using those kind of actuators to do that on off, and the sensor, these are all called sensing layers. These are the field devices. So typically, these are responsible for collecting data from different sources. These can be wired or wireless communication, but majority of them, what you find today, especially when these are brownfield, and as I said, these are IoT, they will be wireless most of the time. These collect the data, and then they send this data to something called the network layer. Now, network layer is basically at times may include the gateways. Gateways do are responsible for providing communication connectivity between devices in the IoT. So, if I wanted to do a actuator trigger from a IQ sensor, I would need a network layer where the sensor would send the information, and then the network layer or the network gateway would send back that command to the actuator. This does include protocols and technologies on which the data transmission happens. At times, we may also include encryption and authentication. Usually, authentication encryption happens at the next layer. Data processing layer, which is the next layer where the process information resides. This is basically a combination of software and hardware components that are responsible for collecting, analyzing, and interpreting data from the IoT devices. It does include data management systems, analytics platform, and learning algorithms. Now, um, so these are this is a data processing, and then which means that we are talking of what we're talking here is, and then the topmost layer, which is where the end user interacts with the system, which is called the application layer. Now, this is fundamentally what we're talking here is a mobile application or a web portal where the user gets to engage with his facility and the sensors that are installed inside his or her facility. That's called the application layer. This is fundamentally responsible for providing user friendly interfaces. So these are typically the dashboards that you get to see, where you have uh, data being after being analyzed and being represented as graphical interpretation, with a lot of dashboarding, with a lot of in decision making data being represented, with a lot of analysis coming in as a through in. And here the end user also has an access to command and control the work philosophy of the system. uh, he or she also has the access to download or to look at various kind of reports of what has happened inside this facility. So that's the way the architecture is done. From a point of representation, if I had to put it across to you, so what you see on the left hand side is the sensing layer where you have the IoT devices which are sending the data to a Wi-Fi onto a cloud, and the cloud here has the data processing being done both in terms of analysis, both and even in case machine learning. Uh, and the cloud server is also storing the data from a point of record keeping. And thereafter, this data is being accessed in the application layer, either as a handful or over the dashboard reports by the admin user. So that's how the architecture of the indoor air quality IoT system works. Uh, so once you've defined what kind of IAQ monitoring you want to do and you've done your selection of devices, a combination of continuous and handheld devices you've thought through the architecture, the next critical piece to look at is the implementation strategy. Now, of course, each sensor will require a placement. So there are placement criteria with regards to what height these sensors should be stationed. Now, you will appreciate that the gases have or the particle size will have different characteristics in terms of their density, in terms of their particle sizes. And of course, to get the best sensing, you will need to ensure that you place various sensors accordingly. Um, so typically, PM10 or 2.5 sensor is best placed when it is 1.1 to 1.7 meter from the floor, which is the breathing zone, which means that the human height, because you would not want to, why would you want to monitor anything which is above? Similarly, CO2 sensors, again, 1.2 to 1.8 meters, VOC sensors. So everything you see here is averaging around the human height. Temperature sensors, I think we all understand, have a different positioning basis, uh, the size of the room and the way the air circulation happens inside the room. There are also distance rules with regards to how far should they be from the wall. So this is very similar to the way the sighting of detectors is done inside a space, knowing that the surfaces do impact also the performance of various detectors. Similarly, here as well, these should be maintained minimum 1 meter from walls, at least 1.5 meter from HVAC vents. So various standards available. Um, and again, from a point of room positioning, it's definitely better. So most of these sensors, as I said, especially the ones which were continuous monitoring, have a large coverage area. Uh, they do detect very effectively the presence of IAQ constituents, anything between 4,000 to 4,500 square feet. One sensor can do it. Now, this sensing, of course, happens in a spherical manner, so it makes more sense to position these sensors at a central location where there is no, ideally, where there is no uh, uh, kind of an interference by a structure or there is no void being created. It should be kept away from corners where the air mixing may become poor. As I said, they should not be behind any obstacle or in placed inside the voids. And of course, these should be also accessible for maintenance or calibration, because that I will again touch upon. Calibration is again a very, very important criteria of how we do the implementation strategy. Uh, some of the environmental considerations that we should take in. We all know there is a very huge impact if your electronics slash sensors do get exposed to direct sunlight. So we should surely avoid that. Humidity again has an adverse impact on the electronics. So high humidity areas should be avoided. EMIs like in detectors can cause a lot of erratic reading. Same thing here. should be kept away. Um, any unstable source where the vibrations are sensed can also again cause a lot of discrepancy in the reading. So vibration should be kept away from vibration sources. And of course, chemicals definitely do have very, very adverse effects. So it should be kept away from them. Now, before the sensors do get deployed, uh, and today most of the sensors do come in as calibrated from the factory. So there is some baseline readings. But still in the field, what we do is 0 point calibration, what we call that. Um, Now, 0 point calibration is fundamentally when your sensor gives an output zero against a zero voltage being supplied, which means that's your typical response. Then there is a span calibration. Now, the span calibration is done for a sensor against a. So let's say if you wanted to calibrate your sensor for CO2. So there are CO2 canisters through which CO2 is or chambers through which CO2 is exposed, and then the sensor is calibrated to respond to already an expected reading out of that CO2 exposure. So that's the span calibration, and then of course cross sensitivity checks against certain standard meters. Post factory calibration, once the sensors are installed at the site, you should allow them 24 to 48 hours settling period so that whatever environmental changes that they're seeing, they settle into that. And then they have some kind of a referencing available. Um, so that should happen. Um, but once calibrated, it's not that you do not need to recalibrate them. So these are not like your fire smoke detectors where once fit it and forget it. You would need to carry out a calibration schedule, and there are some kind of guidelines available. PM sensors um, and PM sensors should be done every 6 months. For VOCs, you could do between 3 to 6 months. CO2 sensors, temperature and humidity are much more stable. So there is an annual recommendation for calibration testing that should be. Nowadays, most of the sensors that come in can be calibrated over the year. It's called OTA, which means that since these are all IoT devices, you do not need to go into the field. But what you could do is that you could actually calibrate them for the difference that they have kind of having from the standard by a central administration from the NOC itself. These do surely need maintenance. Once installed, they will need maintenance. So there are different protocols available for maintenance, which are kind of divided between daily tasks, so weekly task, monthly task, and quarterly. You know how you should look at it, but um, the monthly and quarterly tasks do become more critical. I think the daily and weekly tasks are much of inspections. So in the monthly task, you should look at the sensor, look at filter replacement in case if there is any device which has a filter as well, either replacement or cleaning. Um, and then, of course, look at any firmware updates that have happened. Now, the firmware updates, again, since these are all IoT devices, are done centrally nowadays by most of the organizations who provide these systems, which means the anytime a firmware change happens, they centrally administer it, and that's kind of you don't need a physical intervention most of the time until there is some kind of a bug or a issue. Um, from a quarterly PPM, you should do a deep cleaning of the sensors, battery. If these are battery backed sensor, you should look for the health of the battery. Most of the systems today do report the battery health both locally on the admin's desk as well as the centrally. In case the battery health is going down, then you should surely get the battery replaced during that time and do a performance validation. Preventive maintenance schedules should include looking at the the physical condition, the power supply stability, communication strength, and then of course look at the documentation in terms of what were the issues which were faced, what kind of resolution was done, and where there are performance trends. Um, in terms of troubleshooting, which can happen beyond the regular and the preventive maintenance, the, let's say the breakdowns. So there are again three kind of common issues. One could be the drift, which means that the sensor starts showing you a different reading than what is actually being observed in the field through a calibrated third-party device. In case of that being there, drift, you would need to recalibrate the sensor. But if that calibration also does not correct the sensor and the sensor continues to have a drift regularly, then I think you will have to replace the sensor. Communication network failure could happen. Now, of course, one of the critical elements in the performance of the whole system is and let's say if your system works on Wi-Fi, then of course got to do with the network stability and strength. So that would need to be checked in. But let's say if that side is working fine, which means that you have both network stability and strength, then you will need to look at the device firmware itself, whether it is able to send the information through the network to the server itself. So then you may require an updation there. There could be data anomalies, which means that what is being sent versus what is being reported are not right, or there is a miss of data. In that case, again, you need to carry out perform diagnostic test to know where the gap is. I see some. Uh, Somebody Sridhar has asked me, how is it different from aspiration detection? And I see a lot of systems and can we not have an integration in both icons precision together, which can become the de facto standard? Your thoughts and comments. Sridhar, I will answer this at the end. I hope that's fine. You just asked me a question. Uh, I think I've spoken about it. The deployment does need three considerations. One is the coverage planning in terms of, as I said, most of the sensors today do a coverage of 4,000 to 4,500 square feet if these are continuous monitoring times. But we will need to surely look at the dimensions. Now, if it is an irregular room um, with a different shape than what we expect, then of course we'll need to look at the specific in terms of the dimension, the how the occupancy patterns of that area is. Airflow patterns, of course, is a very critical criteria that needs to be investigated when you're looking at final planning in terms of, and then the risk areas. Network planning is very critical. As I said, Wi-Fi or the network strength plays a very critical role in the performance of the overall system. So both in terms of stability and the strength, and how do you handle the power outages? Let's say your system works well on a Wi-Fi, but then there's a power outage where your Wi-Fi gets shut off and there is some kind of lag in terms of the backup power coming on. So what kind of strategies do you implement so that your IoT device remains up in communication? Again, there are sensors available which have the primary communication over the Wi-Fi network, and in case of a Wi-Fi network failure or a strength drop, they switch on to an onboard M2M card, which means that they start communicating on a M2M network through a GSM. So that those are available. I think that is another critical consideration when we do the planning. Third is, of course, the implementation strategy. I think I've spoken about it again, but we really need to look at what are the critical areas, which are high occupancy areas that need a continuous system, which are low occupancy areas like individual cabins or meeting rooms where you could just go ahead and uh, you know uh, yeah. So there you could use and handle. So those are implementation strategies that could be looked at. Uh, the other side, apart from what goes into the field, is the how do you handle the data management in terms of scalability. So of course, any system that you install, both with regards to field and with regards to data handling that you do, should be scalable. So there has to be a strategy for scalability of how could you do a load balancing for real-time processing, because if there is a challenge in terms of the data being sent from the field versus um, it getting processed at a lag, then of course there will be also a lag in terms of the end user getting that out, and then the whole purpose gets defeated. Um, Data security becomes again a very critical point here, because the data fundamentally is being taken from the facility and being sent through a application software hosted on the cloud and back to the. So of course, the encryption of the data is another critical parameter. Reliability from a point of storage and failover. So how do you ensure that there is a data continuity from a point of availability? Because let's say the server fails, does it have a failover server available where it can be, where the continuity of data is available? Uh, B, of course, in terms of backups, um, because it's just not the instantaneous real-time data that an end user is interested in. He or she for surely looks at investigation into what's happening inside his or her facility over the historical trends of data, which means that the storage does become very critical. And again, if the primary storage was to fail, how do you ensure that there is redundant storage? But most of these are taken care today by the cloud service providers. Most of the IAQ monitoring system service providers work today with GCP or a AWS or Azure. And of course, most of these AWS, GCP, Azure have all these built in into their cloud infrastructure as part of their uh, committed SLA. And performance, again, that's in terms of what are your strategy on the cache, index management, and query optimization. So those are some of the um, more critical elements that should be looked at in terms of data management. Um, Benefits and ROI. Now, what you see on the right hand side, of course, is a 4D. Right now, so we when we do any, so why are we doing indoor air quality? Of course, from a occupant perspective, we want to provide them a healthy and a productive environment, which means that we want to elevate their experience so that they feel like coming back to office to work uh, motivated every day. We want to also impact their emotion positively so that they carry a high brand value. They feel attached to the organization. Have a sense of belonging. Now, so that's the first to ease that any well-designed, well-implemented IAQ monitoring system does, because it helps you diagnose the air quality and also helps you take remediation actions to ensure that both experience and that the emotions of the occupants inside that facility are kind of taken care. The last two blocks which you see, which is the efficacy and efficiency now, um, from a administrative perspective or from a facility manager perspective, eventually, while their key goal is to ensure that the occupants' health, wellness, and productivity gets impacted positively, they would also need to ensure while they're doing this, this does not come at a high additional cost impact. So they would want it to also ensure that the systems which come in also do bring in more efficiency with regards to the energy savings and more efficacy in terms of consistency, which means that it is not one time, but it is continuous. Now, when you think from a administrative perspective, any IAQ improvement and when it is maintained well, surely does drive any energy efficiency across the equipment. Basic example being that if you are maintaining your temperature well, then of course your energy spend does go down. There are productivity gains which does happen in people. Maintenance cost or breakdowns do go down. So those are some of the direct and indirect impacts. Now, most of these can be also calculated tangibly, meaning that IQ definitely has a direct return on the investment in terms of a rupee value or a dollar value. We surely have today models available where we can actually calculate the savings that are coming in because of IQ strategies being implemented from a equipment perspective, from a maintenance perspective. And of course, last but not the least, it does leave you with a enhanced user experience, which means your attrition rates typically tend to go down. Again, there are global data are available that do point out that organizations which have provided well ventilated, less crowded spaces to their employees, there the employees tend to stay higher, which means there is lower attrition, higher productivity, and of course, the users do uh, voice the brand value of such organizations outside in their networks as well. Some of the best practices that we should look at. So there are implementation guidelines. One is we should look at phased deployment approach, especially when we are doing a brownfield. Um, that helps. Uh, Brownfields are slightly tricky in terms of the implementation, so we should look at the integration considerations as well. User training, of course, is very, very critical here. If the training is not given to the people or the users who are going to run and manage the system, and then the whole purpose of the IQ monitoring solution does go down because while the technology does help you monitor and report the data after analyzing, it's the end user along with the fields facilities team which has to uh, use the data to remedify, to manage and maintain. And if that data does not get consumed and utilized to do all this, then of course it's a wasted investment. Some of the common challenges is again I spoken about it, sensor accuracy and calibration. So one is we should ensure that these sensors are accurate uh, with regards to. So there are accuracy uh, specifications. What kind of sensor should carry what kind of accuracy. But calibrations remains a very very critical criteria. While all the sensors do come calibrated from the factory, as I explained few slides back, there is a calibration strategy of how these should be treated in the field. Second, network reliability can pose a very, very large threat. You may have everything well in order, but if your network strength and stability is not there, you may have data misses, and any data miss can cause, again, loss of very, very critical information that may impact your whole strategy. Data privacy does remain a concern, and maintenance. Any system installed works as good as it is maintained. If it is not maintained, then there are all the chances that what you're getting in is either incomplete data or distorted data, and it may really not be. What are the future trends that the industry is working upon? So there's a lot of work being done on AI and ML learning, which means integration, which means that the sensors are being put in the field, left for almost about 3 months, or to learn the environment and correlate with a lot of other factors, which also includes occupancy and other stuff, to use that as a baseline. Um, Mobile first monitoring solutions are of course coming in, which means that instead of having even the dashboards and this thing, you actually can access everything on the mobile, and your mobile can also become a sensor because you're carrying it in the field. Um, and these these systems cannot work in isolation. So there are already a lot of existing smart building systems which are part of the connected solution today. So these do have to get integrated, and most of the cases today, these are integrated with the smart building systems. That's from my side. I know there are two questions already here. One from Sridhar, the other one's anonymous attendee. So I'll answer Sridhar, and of course anybody else who has a question can also surely ask him. So Sridhar had asked that how is it different from aspiration detection system? As I see a lot of system similarities, can we not have an integrated solution, both IAQ and aspiration detection systems together, which can become the de facto standard? Your thoughts and comments. So, uh, Sridhar, I will be honest, I think from a working principle, uh, while you may feel that it is very similar, and there's no two ways about it. So, an aspiration system also works basically on air sampling. The only difference is there is a forced air sampling or an induced air sampling in an aspiration where a fan fundamentally rotates to suck in air from a space and then feed the sensor. And of course, when it does that, it also the smoke comes as a part of the air, which it is uh, the gas sensor or the IAQ sensor also needs the same air to breathe in. I think the difference lies in terms of one when you look at especially in cases where we're talking about aspiration system. Now, in a normal ceiling area, typically which are 10 feet or 3.3 meters, I believe most of the installations today also in India or globally do not use the aspiration system in occupied areas I'm talking about. They typically go with smoke detectors. Aspiration system still, when it comes to public areas, is only being used for high ceiling areas, which means that the pipes are laid at the height of 5 6 meters plus. In fact, by standard, I think the recommended is anything which is 10-meter plus gets done with aspiration, balance are done with beam detectors. So I'm not sure because, as I said in my discussion earlier as well, that while technology is something that we should prescribe, we should also be very, very uh, conscious of the cost impact that brings in. Um, so I'm not sure if I answered it well, but theoretically, what you said, it can be done, but I am talking more from an application perspective. Um, I'm not sure whether I've answered it well. Uh, then there is somebody who's asked, are there norms in NBC for IAQ monitoring and parameters? I guess IGBC lead have few guidelines laid, yes. So there are guidelines available beyond IGBC and lead as well. There is an organization called WELL, which defines actually the guidelines for IAQ, especially from a perspective of impact on the health of human beings inside that space. So it's called WELL. So there are a lot of buildings which are going for WELL certification nowadays. Are there norms in NBC for IQ? Yes, there is a norm in NBC, and there is a committee for IQ which is working within NBC to strengthen these monitoring IQ monitoring parameters. Is there any other query question? And also, the people who ask me these questions, they also should tell me whether I've answered it well or would they want more elaboration. In case they need, I will surely. Uh, I have seen 1 second. So there are a lot of questions. 1 second. Good afternoon.
Because because there is one more question from
Yeah,
Sridhar
I
Madam.
am. Okay, one. Did attempt, which is good and probably, as I understand, the specs need to wait and see how the future can unfold. Okay, Sridhar has commented. Sridhar, of course, you and I can also have a discussion. I'll be more than happy. Truly speaking, Sridhar, I also do understand aspiration as a subject well. Since I have worked with Honeywell and I was the one who brought that product to India. So I'll be more than happy to have a one-to-one discussion with you. Um, Beyond this webinar,
Because
yeah,
just to add on, as far as this aspiration detection is concerned,
yeah,
and we are primarily focusing on the office environment or workplace environment.
correct.
Okay, now if as a FLS point of view, if you see on this, there will be
Yeah,
different fall ceilings,
yeah,
different barriers there, right?
correct,
But
correct.
for the high ceiling areas like warehouses
Yeah,
or airport terminals, where you
Yes.
do not have any such hindrances.
Correct.
So that particular area for the this smoke detection purpose, aspiration is a very good solution.
Correct.
But if
Correct.
you create a hybrid of the system which works on the air quality and simultaneously working on the this smoke detection system,
Yeah.
will be a great challenge from the implementation point of view also. Because
See that.
the
Yeah.
detectors is a spot detector types. So spot detector is very easy to lay out considering the running HVAC ducts and other utility services. So
Vaibhav,
this
just a point here. I'm sorry for interjecting. If you remember when I was talking about the sighting of the IAQ sensors, I talked about a human height. See, the reality is my concern is that what is my air quality at where I have human beings available, correct? And when you take an example of an airport where we're looking at smoke being detected at high ceiling area, we're fundamentally saying we're using a fan to suck in air, which does carry traces of smoke, which has happened because of a fire at the ground. Now, there are two different fundamentals which is happening here, right? So one is this, as I said, the sighting itself. So if I can position, because air also across that 40, let's say it's a 14-meter ceiling, it does vary in terms of the constituent. It's not that what is available at um, 3 meters is the same air constituent at 10 meters, correct?
right,
So that's the reason. While I said it can work, there are a lot of technical differences in terms of how these detectors need to be sited and the purpose for which these are being used. I am
true.
more correct.
Yeah, yeah.
And third, of course, again back to the point, if this was office space and all, I would surely look at the commercial consideration as well, because aspiration sensors are definitely more costly compared to a spot fire detector or a smoke detector. So I would look at those cost considerations as well when I would do that, apart from the technical differences and the application differences of these detectors. But as I said, I'm more than happy to discuss on this. So there is somebody who's asked how incense sticks affects IAQ. Incense sticks, of course, are does produce smoke, um, and that does carry dust particles, ash as we call that, and it will impact the particulate matter. Uh, so Prabhash has asked this. Uh, there is somebody called R. Kumar who said aspiration works on obscuration principle. Yes. So Kumar, we were talking about not using aspiration system for the IAQ. But I think what Sridhar was suggesting was that if there is an aspiration system which is already installed, should we also not bring in IAQ inside that with, of course, a different sensing elements so that they could work in conjunction? Uh,
Because
yeah,
two questions are in chat box also.
I'm
Two.
just going there. Sridhar, I know you may not have access to the mic, but I am just going to. Yeah, so Kumar, you're right. I think we've spoken the same thing on the aspiration and the IAQ with regards to the application. Um, I will, Sridhar, in the chat box, I'm going to share my mobile number and my email ID as well. Um, you can connect to me in person. Anybody is more, I'm more than happy to connect individually. I'll be more than happy to not only answer but also to exchange ideas and to learn from you guys as well, because every input that will come in is going to be valuable to me as well. Okay, so I will put it there. But I'm currently switching to one sec. I think there were some in chat as well. Hmm. In which sectors are IAQ compulsory? Um, this is, I think, if you ask me, all the workplaces today are becoming so. Okay, from a point of compulsion, currently there is no such regulation which has been brought in by the Indian government. Of course, there is a lot of work being done. So I'm just answering Mr. Krishna. Um, um, so that's so when you talk about compulsory, I believe you're talking more from a point of regulation. Is there like today you do not get an occupancy certificate for a building if you do not have fire NOC. So currently there is no such NOC which is there for IAQ, which is required today. Although there are a lot of um, organizations who have starting getting their facilities certified by bodies like Well or Griha, and they do go in because there are scores which are affiliated. But in certain countries, IAQ has already become a regulation. Like for example, in Dubai, by 2030, government has already released this as a regulation. By 2030, every commercial building in Dubai will have to have an IAQ monitoring and a remediation. So they will need to do that by compulsion, by regulation. Uh, I believe India and the government in India has been very highly committed to net zero carbon and sustainability. So we do expect that there is again going to be a lot of uh, regulations. There are already a lot of regulations which are happening around it, and sooner or later this will become part of a compulsory regulation. Uh, then there is Rosanna who asked, monitoring parameters prediction changes territory. I am unfortunately not able to understand this well. Monitoring parameters prediction changes territory. Um, you will have to again please explain to me this query, Rosanna, so that I can answer it well because I'm unable to understand what's the exact question. Sandeep has written, may I get write-up and costing? We have MER 14 written HU. We are keen to display parameters in occupant space and order. Sandeep, I'm going to put my email ID and phone number here. We can surely connect one to one. Which are the hot sectors where we can push hospitals, pharma? Uh, I can, Mr. Krishna, I can truly tell you that today, when we look at this, I'm talking from an India perspective. I'll not talk outside India because there the literacy is slightly higher. But within India, you talk about GCCs, which is Global Contact Centers. You talk about any ITS. You talk about uh, office spaces. You talk about um, um, it's there. It's all there. So IAQ today, I we have got IAQ installed in residential complexes. So I can give you certain examples. The we do so I, as an organization. So I'm sorry, I'm being specific now. But just to help Mr. Krishna understand what kind of facilities taken, uh, we've done a lot of global contact centers, which are investments into the country, and that's the recent trend. We've got IAQ installed there. We have done IAQ monitoring for gyms. We have done IAQ monitoring for plants. We have done IAQ monitoring for IT companies for their large campuses. We've done IAQ installation for SEZs. So yeah, so there is really lots that can go in. Banks, institutions, you surely, Mr. Kumar, are all there. Airports for sure. So every public area has. I'm just typing in my mobile number as well. It's there. I hope I've answered. Okay. I hope I've answered everyone. If I missed anyone, my sincere apologies in case I did. Uh, but I'm more than happy to answer it. now or later, you can surely write back to me, call me up at any convenient time of yours. I'm available 24 by 7. I'll be more than happy to answer them. Uh, yeah. Uh, do we have any other, uh, Mr. Krishna? I just wrote back my contact in the chat box. I hope you've seen it now.
Because you want to take any other questions? Or
I uh, I'm more than happy, but I think people were requesting in the chat box my um oh, I'm so sorry. One second, please. One sec. What I was writing was only appearing to you guys. So I hope now it is visible to everyone. Um, so do feel free to reach out. Um, okay. I think there are a few people, Weber, who requested the presentation. At your convenience, you surely can share that. More than happy if they can benefit from that. And anybody requiring any further advanced details can reach out to me. I'll be more than happy to answer and connect. And I would also like to know you. So it will help me as well.
thank you,
Awesome.
Vikasji.
Thank
Thank
you
you
so
so much
much.
for this insightful session. And I hope participants really enjoyed this technically advanced, all the contents we have shared. And they may get directly in touch with you for further guidance and their workplace specific solutions. It was very nice to have you. And thank you very much,
Thank you, sir.
participants. Thank you very
Thank you
much.
so much. Really appreciate. Really appreciate for having me there. Thank you so much. Look forward.